Well, hello everyone, and welcome back to Adrian's Digital Basement. On today's video, well, it's Wednesday, so you know what that means. It's time for another midweek mini mail call. And on today's video, it's actually a repair video, and I'll be repairing something that someone sent in, and it's for the Apple II. So without further ado, let's get right to it. All right, we have a package here. This one comes from Derek in North Portland. So here in my same city, probably a 10-minute drive away. Thanks, Derek, for sending this in. I feel bad. You could have emailed me and we probably could have met up in a parking lot somewhere and didn't exchange, so you didn't have to actually ship this. But let's see what Derek has sent. As I open this, you might notice I'm using a knife. I can't find the ceramic cutting blade right now. I had it the other day and I used it to open something, and I guess I put it down without thinking, so it wasn't where I normally leave it, which is just over there on a shelf. Okay, we have a note, which I'll put aside for a second. Let's pull out what's in here. Let's check out the note. Hey, Derek, hi from North Portland. Got this in a miscellaneous lot of parts. Since I don't know anyone with an Apple computer old enough to use this drive, I thought I would send it to you. Thanks very much, Derek. Cool, thanks, Derek. Okay, what is this? Yeah, look at that. It's an Apple Disk 2. Is it Disk 2? Drive 2. Disk 2. Disk 2. This was Steve Wozniak's brainchild, these drives, and pretty common on the Apple II, Apple II Plus, and often used on the Apple IIe as well. And it's the later one because you can tell because it has the gray cable as opposed to the rainbow cable. Doesn't really matter though, they all work just as well. Cool, thanks very much. Let's test this out on the bench. All right, the disk drive that Derek sent in all the way from North Portland. These things are definitely workhorses. All these original Apple II disk drives were based on a Shugart drive mechanism that Apple bought very cheaply because I think it was missing the electronics. It just had the motors and the physical mechanism, and then Apple designed their own PCB for it to bring the cost down on these disk drives. Now I'm noticing on the bottom of this one that there's definitely a little bit of signs of rust on the bottom here. Hopefully that is nothing too serious. Okay, that screw is very well stuck on there, but it came off and doesn't look so bad. I think the case is aluminum. So even though these screws are rusty, I don't think this will rust, and since it's powder coated, it should be fine. I have one of these magnet things for picking up screws, and yep, it's not sticking at all to this case, so it's definitely aluminum. There it is, the inside of an Apple disk drive. Let's see. It's a little musty smelling. One thing that is odd right off the bat is the PCB here is not held in properly on this one corner. I wonder if it's been that way since it was brand new. Let's just take the PCB off so I can take a look at the mechanism underneath just to see how it looks. I'm sure it's gonna be fine. This thing is quite clean inside. So there's a wheel down here that this turns and it's supposed to move the heads. The heads don't seem to be moving because I'm turning this and nothing is happening at all with the head assembly. So I guess it's fused in place. Let's try to move this. Oh, no. Okay, no, it's moving fine. Ooh, look at that. There's actually a little bit of corrosion right here. Oh no, that's not corrosion. That's just some buildup of grease. But now the heads are moving when I turn the wheel. So I have some 99% IPA alcohol, and I'm gonna use a little cotton swab here. Just try to clean up the corrosion that I see on this bar here. All right, and I'll just use the other side of this cotton swab. The clean side, I'll carefully lift this up and I'll just give the head a little clean. It was looking pretty clean as it was. There we go. All right, so I have some liquid silicone lubricant here. I'm just gonna put a couple drops on the sliding assembly here. It's what I personally like to use on here. I'm sure everyone will have their own favorites. But that just sort of gets this nice and slidey, if that's a word. Sometimes I just put a little bit onto the cotton swab itself, and then I can rub this on the slider bar here. So this should move nice and smoothly, and it does. With these Shugart mechanisms, I also like to put a little bit of lubricant in the track here for the up and down mechanism. Just makes it work a little bit more smoothly. One last thing I like to do is try to get a drop of bearing oil into this spinny bearing here. It's actually pretty good. Spinning pretty good there for something that's as old as this, but I'm gonna try anyways. So I'm just gonna get this down onto the shaft and give it some spins, spinning very smoothly now. I'm just gonna try to clean up any excess. You need to be very sparing with any oil on the spindle part here, only because it can drip down onto the disc and it's messy. So you wanna try to clean up as much as you can. But now, look at that. That spins like a top. Excellent. All right, so I'm just gonna slide this PCB into its track here as it should have been from the start. The PCB is warped now because it was off kilter for so long. I'm assuming it was probably like that from the factory. And we'll connect the read-write head back up. There we go. And the next step is to test this on the Apple II Plus. So here's the Apple II Plus. Here's a disk controller card for that disk drive. I'm going to connect this up to the disk drive. And the one thing that I think everyone has warned everyone about is you have to make sure when you connect the cable here that you do not offset any of the pins, either one set of pins over that way or over, because there's 12 volts running through here. And you can definitely send 12 volts directly into the controller card on here, which fries chips. So it's really imperative that this cable always go on the right way and you double check to make sure all of the pins are in the correct position. So I have a regular disk controller card to use with my floppy EMU in slot 6. So I'm going to put this disk controller card into slot 5 here so that I can boot off the floppy EMU to get some utilities up and running, and then I can test this disk drive out. Well, I turned on the computer and the disk drive started running at a crazy velocity. Listen. That is not normal. You should not do that. I'm not familiar with what happens on these drives when they're connected incorrectly to the controller card and it fries stuff on here. What they do exactly. Do they run at warp speed like that? After doing a little reading online, it seems that this 74LS125, which I've removed, seems to be what is killed when you hook the cable up incorrectly. So with that chip out, I'm going to turn on the computer and see if it goes spinning. No, it doesn't. Okay, that's a good sign. Let's go to basic. I'm going to go PR number 5, which should initialize this drive. I'm not expecting it to work, but at least it's not spinning. Okay, and when I do PR number 5, the light comes on and it does spin. So I'd say that that chip is definitely bad. So I was looking at my chips that I have in stock, and I don't seem to have an LS125. So I went looking at my old parts and I found this old video card, and it has a 125 on it. So I'm going to pull that off right now, and I'll stick it in this drive and see what happens. All right, some quick desoldering later. There is the 74-125, ready to go back into this disk drive to see if this fixes the problem. All right, the IC is installed. Let's turn on the computer, see if the disk drive goes spinning away. No, it doesn't. Good sign. So if I do PR number 5, all right, well, it's spinning way too fast. So that's still a fault. At least it doesn't spin when it shouldn't spin. So that chip is doing its job. But what is wrong with the speed controller on this thing? So on the back of the drive here is the speed controller, and it does have a potentiometer here that is adjustable for the speed. Now I wonder if someone went crazy and tweaked this when they shouldn't have. Let's start up the drive and see if that actually is affecting the speed at all. No, I don't think it is. No, this has no effect at all. Let me turn off the computer. This can't be good for it running it that fast. So now I think I need to do a little troubleshooting on that speed controller. Luckily, this mechanism and the schematic for the speed controller, I think, is well documented and well understood. So that means that this board here just turns on the motor, which turns on the speed controller. I think there's not a fault here. The fault exists on that board. So I removed the disk drive from its enclosure. Interesting, on the bottom, there was the belt. It's right here. I took it off. But there's a little bit of, so to speak, fluff under here, maybe from the corrosion of the aluminum, because it clearly was exposed to quite a bit of water, hence the rusty screws and stuff that we saw. But right here, there's a lot of fluff, and also on this part here and there. So definitely water got into this. So it may well be that the motor is messed up. In fact, when I turn it, I don't know if it's going to come across on the camera, but it makes kind of a clicking noise. So that motor is not super happy. It may be faulty, and there is a tachometer inside there that helps regulate the speed. So that could be one of the reasons why the speed is unregulated on the motor control. So if I flip the drive like this, we can see the motor control board. The 12 volts DC from the computer comes into this board, and with the help of a tachometer signal that comes from the motor right here, this regulates the speed. Now there's an IC right here, the main switching transistor here, there's the potentiometer for adjusting the speed. So clearly something is going on with this board or with the motor that causes the motor to run at full speed when 12 volts is supplied. I'm going to pop off the connector that goes to the motor control board, and I want to actually feed 12 volts directly into the board, and then I can use the oscilloscope, which is sitting right here on the bench, to probe some of the signals on here to see if I can figure out what's wrong. Earlier in the video, I had said that the speed controller was pretty well understood because this is just a Shugart drive mechanism that Apple bought without the disk controller analog board, they're calling this, and they put their own on here. So I was under the assumption that this speed controller board was the standard one from Shugart. Well, I printed out some schematics from the service manual for the Shugart SA400 disk drive, which is the actual mechanism that Apple bought here, except the SA400 has the MFM controller card that would be used for IBM PCs and things like that. And taking a look at these two different schematics, there's two different versions it talks about for the speed controller, and unfortunately, neither of them are the right one. In fact, this here is the component layout of the two versions, and if I flip the drive up, clearly it's pretty plain to see that this board doesn't match either of these. This one here has a regular dip IC there, and this one up here has a large switching transistor and the speed adjustment there. And that is nothing like what's on this board right here. So I was chatting with my friend Frank about this disk drive and the problem I was having, and I sent him a picture of the speed control board, and he said, that board looks weirdly familiar. And then I told him what the IC was on here, this sort of upright package right here. I mentioned what the part number was, and he said, oh, that's used by Commodore on 1541s. And sure enough, here's a 1541 drive mechanism. This is what's inside 1541. And this is the ALPS mechanism. There are two different types of mechanisms, Neutronics and ALPS, and this is ALPS. And if I flip this over, look at that. There's the speed controller board, and it is identical to the one on the Apple disk drive. The only difference is the potentiometer for adjusting the speed is mounted sideways so you can adjust it straight. And on the Apple drive, it's adjusted so it's a component where you can go through the side. That's it. I'm assuming the boards are completely interchangeable. So I have, as a last resort, this is a parts drive, so I could take this controller off and put it on here if I need to. But because we know now that it's off of this ALPS mechanism, that allows me to find the schematics, which I have printed out, and here they are. So this is the ALPS motor control board schematics. It's a little rough, but I don't know where this came from. It's from the Commodore 1540, 1541 service manual. So I found this online. It lists all the components. So with the schematics in hand, it allows me to be able to probe, for instance, the tachometer signals and figure out if this IC is actually controlling the motor speed properly, or if perhaps one of these semiconductors over here, like Q2 or Q1, is faulty. So first things first, I'm just gonna take this board off of here. Hopefully this comes off pretty easily. Yes, it does. There are these little bushings here to space the controller off of the disk drive. Oh yeah, I forgot to mention that the IC chip on here is a Sony CX065B. And that's what's taking the tachometer signal and then creating the correct signals to vary the speed of the DC motor to maintain the 300 RPM. And unfortunately, if the Sony part is bad, I don't have any extras around. Although if we figure out it's bad, I can just take the board off this parts drive. But nonetheless, that's the only part on here that I probably don't have a replacement part in stock. So if anything else is bad on here, I should be able to fix it. All right, the first thing I want to do is hook up the bench power supply to this drive so I can get that motor spinning. And C1 capacitor here has 12 volts in ground, so that's where I'm going to be connecting it up. And on the board, C1 is this capacitor right here, so there's the plus and there's the ground. So I can just hook straight up to that with my bench power supply and run this thing, at least the motor, directly off the bench supply without even affecting this analog board at all. All right, bench supply is hooked up. Let me turn this on. Okay, there it was, running super fast. Could you hear that? Let me do it again. Definitely, that's way faster than it should be running. All right, the scope probe is connected to the ground. And first I'm gonna probe for the tachometer signals, which is on this bridge rectifier right here. So it's on CR3 and also on the band side, which I can never remember if that's cathode or anode, of CR4. Those are the two tach signals. So CR3 is right here. Now watch the oscilloscope when I turn on the power supply. There we go, that looks good. And we'll check CR4, we should see that as well. And we do. So a tach signal is coming from the motor, so we know that is all good. So I flipped the board over and I'm gonna check on the Sony IC to see if the tach signal is coming through these diodes and getting to the board. And I did check the diodes with diode check on my multimeter and they all look fine. So the signal is gonna be here. So the tach signal should be found on pin 1 of the Sony IC. That's the input for the tach signal. There it is, it's looking good. So you might be wondering why the motor runs as soon as I power it up, while with the disk drive analog board connected, it doesn't. And that's really because the motor on signal here is a ground that comes from the disk drive. And what it does is the output from the IC is being grounded when this is being grounded here through Q1. And there's a resistor R4, and if we look here, R4 is 3.3K ohm. So when this transistor here is turned on, this is probably 5 volts or it's more than ground. And what this does is just grounds the input here to Q2 on the base, and that shuts it off. Well, I have been trying to figure out what's wrong with this, referring to the schematics, checking this out, and I cannot find anything wrong with this. I can definitely confirm the motor is spinning way too fast. This is giving basically a full 12 volts to the motor when it shouldn't be getting that much voltage. But all of the semiconductors, the diodes and transistors all check right. None of these caps are shorted, no shorted tantalums. Because looking at this, it's possible that with maybe a shorted cap, it could also run all the time, but that doesn't seem to be what's going on. I cannot figure out what's going on with this, which leads me to believe that it's this Sony IC here that has gone bad. That's all I can think it can be. Before I swap the board over, let me just power it up one last time and we'll check out the speed on the tachometer reading and see what that is, and we'll compare it to the board that's working once I swap it over. So I'm picking the tachometer signal off CR1, and we're getting 1.69 kilohertz or thereabouts. And just so everyone knows, I'm gonna adjust the adjustable potentiometer here, and it has absolutely no effect whatsoever. Yeah, I'm turning it right now, and it's not doing a thing. So actually, yeah, 1.72 kilohertz. So the board from the Commodore 1541 is all soldered up and ready for testing. Let's hook this up to the bench power supply. And first I'm gonna turn this on and just see if the motor sounds like it's going out of control or it's going the right speed. All right, that sounds like it's going a lot slower. Let's check the tachometer speed output on this scope here. And there we have it, 720 hertz. Let me turn the potentiometer for the speed control. And it absolutely is working perfectly. It's now going 707 hertz, 791. Definitely speed control is working. So I'm gonna flip the drive over and check the little wheel thing on the sticker on there to see this thing here, whatever this is called, the timing wheel, I guess. And let me see if the 60 hertz ring is the right speed. Look at that. Absolutely is. And I can tell you before that that thing was not in time at all. It was running far too fast. Let me try adjusting the potentiometer here. So hopefully that shows up in the camera. It's going too slow. There we go. That's about right. All right, I'm gonna reassemble this board back onto the back of the drive, and we're gonna have to test this on a real computer. And while I am down here, I'm gonna clean off a little bit of this fluff here, this aluminum oxide, whatever this stuff is called here. Yuck. Now the board's all screwed on. It's pretty cool that apart from a Commodore disk drive is potentially going to fix an Apple II disk drive, especially one as old as this. That's the chip I swapped out, but that chip there has a 1981 date code, and so does that, and this one does not have a date code on it. Now, before I hook this drive up back up to the Apple II, one concern of mine is that some of these other ICs are bad on here. And unfortunately, for instance, this one right here is a ULN 2003. I don't have any of those spares. So if this drive is still not working, then it could be some of the other ICs got damaged, and I'm going to need to order those before I can fix this drive. Okay, we're back on the other bench. Everything is ready to go. Disk drive is connected. I made extra special careful sure to make sure the cables are connected correctly. That pin 1 is lined up with the stripe here and on the card. Nothing is misaligned, so we should be good to go. When I turn this on, the disk drive should not run. Here we go. There we go, that is correct. Now the floppy emu is on slot 6, and I'm gonna do PR number 5. Okay, it sounded normal. So I'm gonna pop a disk in there. Let's just go for broke, see if this thing boots. I have a copy of ADT Pro. It's Pro-DOS disk. Regular games and stuff, they don't like to be on slot 5, but Pro-DOS should have no problem booting off slot 5. So turn this back on. PR number 5. Here we go, fingers crossed. Look at that. Look at that, it's freaking working. That is just awesome. How cool that disk drive is fixed. I'm gonna reboot the computer and boot off the floppy emu. I have a copy of Apex, which I think is a disk drive diagnostics software, Apex 2. Apex 2 has identified this thing as an Apple II Plus 64K, that's correct. Super serial card in slot 2, that is correct. VIDX 80 column card in slot 3, that is also correct. And I have a disk 2 controller in slot 5 and 6, that is correct. It is missing the CPM card that is in slot 4, but that's fine. All right, let's try the disk drive test. Why don't we do disk speed? Hopefully this doesn't destroy the disk. I could just make another copy. We're gonna do slot 5, drive 1. Here we go. Okay, it's ever so slightly slow, which is okay. One of the issues, of course, I didn't switch the potentiometer on the drive, which means adjusting the speed while it's mounted in the case, not really possible, but I'm gonna try. I probably should have moved the potentiometer over, but I think I can do this. Maybe. Let's see here. Okay, yeah, I can definitely adjust it. So now it's way too slow. And I'm gonna turn it up. Oh, too fast. All right, it's close enough. It did adjust. I do notice here, scratch disk will be erased. Darn it, I'll have to make a new copy of ADT Pro. Not the end of the world. Let's try rough alignment test. It's probably gonna need a formatted disk for this to work correctly. Maybe, we'll see. Cool, okay, overall rating is 80% good. I have no idea what's good and what's not. Radial positive alignment is 8.80001. Same thing here. Median differential -8. If anyone knows what a proper disk drive on the Apple II would say on Apex, please let me know. I'm just gonna give this drive a quick clean and put it back together. When reassembling this drive, I did not reuse the rusty screws. Luckily, the threads on the existing holes were just standard PC case screws. There wasn't much to cleaning this drive. A little Windex, some elbow grease, and a magic eraser cleaned it right up. And with that, we have one working Disk II drive from Apple. An amazing piece of technology, really cool, ingenious design that was really inexpensive compared to all of the other contemporary disk drives at the time, thanks to Steve Wozniak's incredible ingenuity. And all that was wrong was a bad 74LS125, which is here, it's the bad chip. In fact, let's put an X on that, just so I know this is bad. And let's bring out the bad parts bin, which is completely overflowing with chips right now. I really need something a bit better than this because it's so full. Anyhow, okay, so bad chip, and of course the bad speed controller board. This was the Commodore 1541 drive that I stole the board off of. I put the bad one back on here. I didn't reattach these wires. This is completely a spare mechanism, so no 1541s were harmed. The rest of the 1541 that this came out of was destroyed. So I kept this mechanism as a spare, and it gave part of its life to fix the Apple disk drive. Awesome. So thank you very much, Derek, for sending in this Apple II disk drive. I've never done any repair work on one of these before because they're so robust, and all of mine have worked. But I think for sure that this thing was originally plugged in incorrectly into the disk controller card, which killed that chip. As for the speed controller board, I don't think that died because of a misconnection here, but anything is possible. If anyone has any experience with those speed controllers going bad and having that runaway speed, please let me know in the comment section below. I'll be very curious, but personally, I've never seen that myself. So with that, that's gonna be it for this video. I hope you enjoyed it. If you did, I'd appreciate a thumbs up. If not, you know what to do and all that YouTube-y stuff. And stay healthy, stay safe, and I'll see you next time. Goodbye.